We are building the number hunt program from the YByte Python curriculum. In the last video, we saw the intuition behind this algorithm called binary search, which is both efficient and correct. In this video, we are going to see how we can implement this in Python. So I'm going to do it right here in the program that I've been developing. Recall that I was at a point where my previous algorithm was one which had larger step sizes in the beginning, and then the step size used to reduce. Now I'm going to do this all over here. Now let's just give a few, maybe a comment here that look binary search so that it becomes clear. Now here I can put a couple of print statements. So I say, okay, print, let's say 2 empty print statements. And then I can even print a statement, look, I will be smarter now. I will do binary search. Now, this I here refers to the computer because finally remember it's a computer that's doing the guessing. Now, as you can imagine that the fundamental crux of this logic is still going to be based on a while loop. So I can in fact take whatever I've done previously and leverage that because that will help me rather than typing it all over again. So I'm just going to take, this entire code and, put it over here. Of course, we need to modify this code and we'll do that in a moment. But before I do that, I just want to highlight once again that notice I want to make sure that my subsequent statements from say line 72 onwards have nothing to do with the previous while loop, which means that I must bring them back to the base indentation and make sure that the previous while loop is completely over. And that's what I've done here. Now let's just get back to this. Again, I need to set the done flag to false because, indeed, the loop needs to run again. I will go ahead with attempts. Now guess, I don't need guess step in previous answer, so I'm going to remove these two. Guess itself, we'll look at it a little bit later. Recall my binary search used to work with 2 variables, low and high. I'm going to set low to say, 1, high to 100. That's because that's my initial range. And, let's just go through this code carefully. While not done, keep doing this. Now we still have not, let's say, done the guess over here yet. We'll do that a little bit later. But this part remains exactly the same. I don't need this print. In fact, we'll put a different print later on. I don't need any of this. So I can just remove this code. Just be careful on the indentations. Now let's see what happens if the answer is S or say L. Now if the answer given is S, it means that the number that we have chosen is smaller than the number the computer has guessed, which means that I must now limit my search range by saying that high will become equal to the guess that I had. Because remember, basically this means that the higher range can be eliminated, and hence I'm going to set the guess, just the high value to guess. On the other hand, if I answer L, it means that the number that I have chosen is larger than the number the computer has guessed, which means that I can set the low to guess. And in fact, this is pretty much all we need. Of course, we haven't yet come to the guess. We'll look at that in a moment. When the answer is yes, in fact, the entire code will remain. So I can just kind of close this whole thing over here. Notice this is my new while loop, and this is what I'm going to update to become my, let's say, the binary search. Now, before I get on with any more code over here, I just want you to focus your attention, let's say, to the console. I'm just going to define for now, let's say, low is equal to 1, which I do from the code as well. But it's a little bit more clearer if we can see it beforehand. Now, recall that previously we said that, okay, we'll approximately go to the average of this. But then if I were to do the average of low plus high, let's say, divide by 2, I find that that number is not an integer. It's like 50.5, which doesn't make sense for me. So as we discussed previously, we can use the round operator to go to the nearest integer. Now, when I do this, it becomes 50. Now, there's something very interesting here, which is that, let's say, if I were to have, let's say, low of say 1, high of say 50. Now, in fact, the average of this, so again, if I did low plus high by 2, it's in fact 25.5. But when I do round of this, it comes to be 26. Now, this is something a little bit strange, I would say, because notice in this case, we kind of rounded down, whereas in this case, we are rounding up. Now, what I would suggest is do not get too caught up with all this nitty-gritty. That's all right, because like I said, this algorithm will converge anyway. We can even go consciously to the lower integer or higher integer, but that's all right. We can stick with round over here. So long as we get an integer, that's fine. before we put this in the code, I also want you to realize that we must put these brackets, because if we don't do this, for example here, if I were to do low plus high by 2, now this is, it turns out 26 in this case, but this is not correct, because remember, division has a higher precedence than addition. So what we are doing is low plus high divided by 2. It just works out to be correct over here. What we must do is the average of these two, and I do that by forcing the low plus high to happen first by putting that in a bracket, because remember, parentheses or bracket have a higher precedence than the division. So this will happen first, and then we'll divide by 2. So this is in fact correct, and of course, like I said, you can do a round operator on that. So what I'm going to do in short is that in my code over here, I'm just going to say, okay, look, the guess should be equal to round, let's say low plus high. Now be careful on these things, don't go too fast, do slowly, make sure you put all the brackets over here. So basically low plus high by 2, this looks okay to me. Now just for the sake of, let's say, understanding, I'm going to put some extra prints over here. I just say, for example, let's say low is equal to, say, space here, say comma low, and say high is equal to, for example, say comma high. Now let's run this algorithm. Now in order to just speed up the whole process of development, let us make sure that our code skips the previous while loop. Remember this searching, with larger steps and so on. And it's very simple. All I need to do is to go and for now set this to true. Later on, we'll set it to false again, just to make a comparison. Now let's say my number that I've chosen is, say, 37, right? So let's see how this algorithm runs. When I run this code, remember the first two loops are going to get skipped. So really, if I click enter, it creates 2 extra prints. And then it says I'll be smarter now, and I'll do a binary search. In the beginning, remember, low is 1, high is 100. So I make a guess in between those two using this round operator. I ask, is it 50? My number is 37. So I say, well, it was smaller than that. Notice what happened here. Low did not change, but high became 50, because I know that the number is smaller than 50. And now I'm making a guess, which is the average, sort of the average of these two, 26. Well, my number is larger than 26. Notice what happens. The moment I say larger, my low becomes 26, high stays at 50. I ask, is it 38? Well, my number is actually smaller than that. The moment I do this, notice my high has become 38. I know my number is between 26 and 38. I'm converging really, really fast. I ask a guess, which is the average of these two numbers again. Is it 32? I said, well, it's larger than that. The moment I do this, now my low is 32, high is 38. It's very logical. Well, is it 35? I said it's larger than that. It says that, is it 36? Again, I say it's larger than 36. In fact, it asks me whether it's 37, and indeed the answer is 37. And I took exactly 7 attempts to get there. Look how nicely this thing is converging. Let's take one more example just to be sure that we are understanding this. Let's say this time the number is, say, 98. It's a very large number. Let's just see how that goes. So I click enter. When ready, it asks me, is it 50? Well, it's larger than 50. So I say L. Notice my low becomes 50, high is 100. Is it 75? Because my guess was right in between these two. Well, it's larger than 75 as well. So it says, is it 88? Again, because my low has become 75, high is 100. It picks a number in between those two. I said it's further larger than this. My low becomes 88, high is still 100. It says 94, because right in between these two. I said, well, it's larger than that as well. It goes to, well, is it 97? Because my low is 94 and high is 100. I'm converging fast. I know it's still larger than this. So I say larger than that. It picks a number, just happens to be because of round and so on. It says, is it 98? And I say, yes, indeed, it is 98. And it took just 6 attempts to get there. Now, you can clearly see that this is a very powerful algorithm now, and working quite well. I hope this gives you an idea. For the final thing, we can just remove this print, and let's just for once run the entire program. And I'm going to just do that by, for example, saying done to say false. So false, because that way my second while loop will also run, and I'll also go and make the very first one to say false. This way my entire code will run, and let's just go through this process. In fact, I'll remove the other print as well, so that we can just see it working. Now remember, the game starts with saying I've selected the number be 100. Can you guess? I said, okay, well, maybe let's just try binary search. In fact, I say 50. Smaller than that, I try, let's say 25. Is smaller than that, so it's between 1 and 25. I can try, say 13. Larger than that, 13 and 25, I can try, let's say 13 plus 25 is 18, so around, say 19. Is larger than that, now it's between 19 and 25, so I try to say 22. Larger than that, I try, say 24. Smaller than that, I just try 23. 7 attempts and I've done it, right? So because basically I've just implemented a binary search. Now let's say my number is, say 23. So again, I'll say, okay, look, I enter to ready. Is it 1? Larger than that, 11. Larger than that, smaller than 31. So I reduce the step size. Larger than this. Now I'm going to just do a bit of flip-flop over here. Smaller. 23 was my number, so I will just say yes. Now in this case is not bad. Again, I got it in 7 attempts, but let's see binary search here. 23 is the number. Task, is it 50? I said smaller than that. It makes it, is it 26? I said smaller than that. Is it 14? I say larger than that. Is it 20? I said larger than that. Is it 23? I said yes, and I'm done. So now this is the entire program running 3 while loops. Quite interesting, a Python program. Think about every step of this, both the algorithmic angle as well as the Python angle, the indentations. A lot of learning will happen as you go through this entire program. If you enjoy learning like this, do look at our website, because there are many activities that we have, many videos. I'm sure you're going to enjoy this. Take care. Thank you so much.